75,000 years from now, a man-made object tears into the atmosphere of an alien world, burning white-hot before violently ripping apart. To understand how it gets to that catastrophic moment, we have to look back to its liftoff in 1977. Voyager 1 launched with a relatively modest goal, marks it as the furthest human-made object ever. But the power required to maintain that connection is vanishing. Sometime around the year 2036, the probe's decaying plutonium energy supply will drop to absolute zero. When those nuclear batteries finally fail, Voyager 1 will go completely silent. Unable to receive commands from NASA or send any telemetry back, it becomes a drifting, unpowered ghost ship. That lack of power makes navigation impossible. Right now, its trajectory is pointed at a barren star system lacking any planets, far from Proxima Centauri b. To reach that target, the dead probe has to cross an interstellar gulf spanning 4.5 light-years to arrive in an entirely different star system. Without fuel or a functioning computer, a probe cannot correct its course. How does a dead, frozen hunk of metal navigate across that interstellar void to hit a specific alien target? Fast forward 3 centuries into the future. The silent probe reaches the Oort cloud, a freezing, chaotic sphere surrounding our solar system that is packed with trillions of icy comets. Because it has no thrusters, Voyager's only mechanism for changing its direction is a gravity assist. This diagram shows how the maneuver works. A spacecraft approaches a massive body, dips into its gravitational pull to steal its momentum, and gets whipped outward on a newly bent trajectory. To align with Proxima Centauri b, Voyager has to drift for another 30,000 years until it encounters a massive, undiscovered ice giant lurking in the dark, a theoretical body known as Planet 9. The math is unforgiving. Humanity's ghost ship will only reach its final destination through a blind, unpowered slingshot off a hidden rogue planet. Once it makes that turn, the physical environment becomes increasingly hostile. 40,000 years into the journey, Voyager is constantly bombarded by galactic cosmic rays, high-energy particles fired by supernova beyond our sun's protective bubble. These particles displace atoms within the aluminum's crystal lattice, accumulating microscopic defects over tens of millennia. This radiation damage turns the once malleable hull as brittle as a ceramic plate. After 75 millennia in the deep freeze, the fragile ship finally approaches Proxima Centauri b. It's a harsh world, where one side is trapped in eternal darkness, while the other is constantly baked by extreme ultraviolet radiation. The planet's gravity grabs the probe, and the entry is immediate. Voyager slams into the alien atmosphere at 20 kilometers per second, possessing absolutely no heat shield to dissipate the friction. The kinetic energy turns to extreme heat instantly. The brittle hull shatters. The camera housings, the long boom arms, and the iconic antenna melt and vaporize in a fraction of a second. It took 75,000 years to cross the interstellar gauntlet, but in a matter of seconds, the sky consumes the spacecraft. Yet, out of that molten destruction, 2 components survive the atmospheric impact: the heavy-duty shells surrounding the nuclear batteries and the golden record. This gold-plated copper disc was curated by a committee led by astronomer Carl Sagan to carry a record of human civilization across the deep future. The microscopic grooves of the record hold the cultural footprint of Earth, from greetings in dozens of languages to the music and photographs of our world. But space has a cruel sense of irony. Over 75,000 years in the ether, abrasive interstellar dust will have entirely sanded off the microscopic, high-frequency audio grooves. The music and the voices of humanity will be permanently silenced, leaving behind only a warped physical disk resting in the alien dirt. While the delicate audio data is destroyed, the deep engravings etched into the record's outer cover are sturdy enough to survive the crash. Look closely at the lower left quadrant of the cover. This starburst pattern is a cosmic map. It uses the unique spin frequencies of 14 different pulsars, the dead remains of spinning stars, to triangulate the exact location of our sun. Deciphering these geometric lines provides an advanced alien civilization with our permanent coordinates in the galaxy. Even then, the spatial distances are so vast that a simple radio signal saying "we found it" would take tens of thousands of Earth years just to cross the gap. Voyager 1's destiny was never to arrive intact or call us back. Its purpose was to absorb the punishment of deep space and sacrifice itself, so its charred remains could serve as proof that for one brief moment, humanity reached out into the dark.